In our previous video, we tried familiarizing ourselves with function, where we get to understand the types of a function. And today we're focusing on one of the types, and that is one-to-one function. And so, given the function f of x to be equal to 1 over x plus 3, show that this function is a one-to-one function. Well, for a function to be one-to-one, then f of a of the function should be equal to f of b of the same function, where a will be equal to b. Well, so what I was talking about is when you say f of a and then f of b. For f of a, we'll be having 1 over a plus 3, and then for f of b, we'll be having 1 over b plus 3. 1 over b plus 3. Now for f of a, wherever we see x, we replace it with a, and for f of b, wherever we see x, we replace it with b. Right. Based on the condition that f of a should be equal to f of b, then we can have 1 over a plus 3 being equal to 1 over b plus 3. Now, by cross multiplying, we can have a plus 3 being equal to b plus 3. Now, try making a the subject. Then our a will be equal to b plus 3 minus 3. Now, plus 3 can take away minus 3, and so we'll be having a being equal to b. Having a being equal to b from f of a being equal to f of b then follows that the function is a one-to-one function. And so now having another problem where we have f of x being equal to x squared minus 9 all on x, where x should be greater than 0. Will we say that this function is one-to-one function? Well, for a function to be one-to-one, then f of a must be equal to f of b of the same function, where a will be equal to b. Now, our f of a of the function will be a squared minus 9 all on a squared, and then our f of b of the function will be b squared minus 9 all on b squared. Now, based on the condition that f of a must be equal to f of b, we cannot have a squared minus 9 all on a squared being equal to b squared minus 9 all on b squared. Alright, so by doing away with the fraction, we can cross multiply, and so we'll be having b squared multiplying a squared minus 9, which will be given as b squared multiplying the bracket a squared minus 9, and then a squared multiplying b squared minus 9, a squared multiplying b squared minus 9 will be given us a squared multiplying the bracket b squared minus 9. Now I want to expand the bracket and see what is going to happen, and so a raised to the power 2, that is b raised to the power 2 multiplying a raised to the power 2 will be given as a raised to the power 2 by b raised to the power 2, and then b raised to the power 2 multiplied minus 9 will be given as minus 9 b raised to the power 2. Now expanding the other bracket, that is a raised to the power 2 multiplying b raised to the power 2 will be giving us a raised to the power 2, b raised to the power 2. And a raised to the power 2 multiplying minus 9 will be giving us a raised to the power minus 9, a raised to the power 2. Now we're having a raised to the power 2 multiplying b raised to the power 2 on both sides, and so they can cancel out. We'll be left with minus 9. We change the color. We left with minus 9 multiplying b raised to the power 2 minus 9 multiplying b raised to the power 2 being equal to minus 9 multiplying a raised to the power 2. Now we are out of space, so we get some space. Some more other space. Some more space. Alright. So now dividing both sides by minus 9. Now minus 9, we take away minus 9. Minus 9 will be minus 9. And now we'll be having b squared being equal to a squared. But now we are interested in a and b, not a square and then b square. And so we're taking square root of both sides. And then which will give us b being equal to a. Now since a is greater than 0, we conclude that the function is 1-to-1. Well, someone might ask, what are the possible answers for a, not plus or minus, for the sake of the square root? Yes, you are right, but for the condition given from the question, it suggests that the value for a should not be less than 0. And so we ignore the negative part of the possible answers or values for a. If you find this video helpful, please consider subscribing and leave your question in the comment section below. I'll be glad to attend to them as soon as possible. Thanks for watching.